Today we're going to practice going from standard form of a quadratic to vertex form. We do this for many reasons to get different information about our parabola. So the first thing we're going to do is we're going to take our constant term, 9, and we're going to transform it by moving it to the left-hand side. This is going to isolate our x terms, leaving us with only x squared minus 4x on the right-hand side. So now, in order to manipulate the right-hand side to make it a perfect square, because remember in vertex form we're trying to get to a perfect square, we're going to need to add something to the right-hand side. And whatever we add to the right-hand side, we're also going to want to add to the left-hand side to make sure that we're balancing our equation. So I'm just setting us up to see that we're going to add something to both sides of our equation. In class, we talked about doing this two different ways. So one of the options we talked about is taking our b value, which is -4. We're going to cut it in half and we're going to square it. So in this situation, because in our quadratic b is equal to -4, we talked about doing -4 divided by 2 squared. This means that we had -2 squared, and -2 squared was equal to 4. And I want to point out that specifically -2 was the magic number. And in this case, this means that we are going to add just, so we're going to hold off on thinking about the magic number, and we're going to add 4 to both sides of our equation. So let's talk about why we added 4 and what our new trinomial on the right-hand side can be transformed to. So another way we talked about thinking about this is by using box method. So I'm going to just take a moment to talk about how when we're completing the square, we can also think about it using box method. So on top of this, I'm going to write where we started. So we really started with x squared minus 4x. And hang on, let me write it on the top. Okay, so we really started by thinking about this as x squared minus 4x plus something, right? So again, I'm going to put this in pink, or plus something, and we don't know what we're going to add. So based on this x squared minus 4, we know that in this upper left-hand side, we're going to have an x squared. And because we want this to be a perfect square, that means we're going to split the -4x evenly. So if I do that, that's going to result in -2x in both of these terms. Because again, I want to make it a perfect square. Which means if I'm thinking about my box, I know that on my top I have to have x minus 2, and on the left-hand side I have x minus 2. And now if I'm thinking about what's going to go right here in this box, we know that -2 times -2 gives me 4. Which again, I just want to note, is the exact same 4 that we got here and here. It's just two different ways of thinking about it. So we're really going to add 4 here. And notice that in our box method, this means that we're left with x minus 2 times x minus 2. So I'm going to come back to my original equation that I was working with, and I'm going to simplify on the left. We have y minus 9 plus 4, which leaves me with y minus 5. And then just like I saw in my box method and using my magic number, I can see that x squared minus 4x plus 4 can just be rewritten as x minus 2 times x minus 2. So again, we just transformed our equation. So what we're seeing both here and here are exactly the same equation, just written in different forms. All right, so now this x minus 2 squared, I can simplify even further and say that it's this x minus 2 times x minus 2. I can simplify and write it as x minus 2 squared. Now, because I want to think about vertex form, and vertex form is going to be y equals a x minus h squared plus k, I really want to isolate y at the very end. So in order to do this, I am going to add 5 to both sides of my equation. And when I do this, it's going to leave me with y equals x minus 2 squared plus 5. And if we'll see here, we now are in vertex form. And from this equation, I can tell two different things. I can tell one, so far, that my equation is upward because there is an imaginary positive 1 here, and it's not negative. So this means that my parabola is facing upward. So if I'm imagining, and then we can like kind of envision where our parabola is. So in a minute, we'll try to envision where it is. So it is an upward facing parabola. And I can now tell the vertex. So we have our x coordinate for our vertex, which is coming from here, and our y coordinate for our vertex is here, because h and k represent kind of the x and y of the vertex. And notice, because in this equation for a vertex, because in the equation for a vertex, we are subtracting the h value. So if you see here in our equation of a vertex, we're subtracting the h value. This means that the number inside of the parentheses after x is going to change terms. So really, my h value is going to be positive 2, because x minus positive 2 leaves me with a negative 2 in my parentheses. And I'm adding k, so it's just going to remain the same sign. So my vertex is 2, 5. So I can also add that to my knowledge, where my vertex is 2, 5. All right, so I can imagine if I wanted to sketch my parabola, that at 2, 5, and again, this isn't going to be a perfect parabola. Imagine that's 2, 5 here for my vertex. And I know that my parabola is going to be upward facing, so I can imagine kind of sketching an upward facing parabola and having it look something like this.